All right. So today we get into our final transformation, which is called dilation. Okay. So a dilation is a. We done? Dilation is a transformation that produces an image that is the same shape. Okay. Which means our keyword similar as the original, but not the same size. Okay. So like I said before, dilation is similar to the original figure. And they're also centered around the origin, 0, 0, unless otherwise stated. So there's some things that have come into play here. As you learned in 7th grade, scale factor, right? So scale factor is the image length and the pre-image length, right? Which is a ratio. Remember that word? So if the scale factor is greater than 1, okay, if the number is bigger than 1, the figure becomes larger. Kind of the same thing with an exponential function, right? Every time the growth factor was bigger than 1, it was a growth, right? When it was less than 1, it was a decay. So the growth factor is between 0 and 1, the figure becomes smaller. All right. So move this down just a little bit. So if we were to write a rule, so if the scale factor is 3, that's bigger than 1, right? Right? That means it would dilate bigger, right? How would you write the rule? Well, again, when we write rules, x, y, okay, when we translate it, will be, if its scale factor is 3, that means we're taking 3 and multiplying it by whatever the original coordinate is. So it would be 3x, 3y. So the easiest part about dilations is you just multiply the coordinates. So if our original coordinate was 2, 3, it becomes 6, 9 is the dilated coordinate because you'd multiply it by 3 and 3 each coordinate. Okay. Example 2 says, triangle ABC has vertices at 0, 2, 4, 4, and negative 1, 4. What are the vertices of its image if the scale factor is 4? So let me show you how we do this now. So if the scale factor is 4, that means our rule is this. Okay. So 0, 2, the image of A, if we multiply each coordinate by 4, what will we have? What was it, Jack? 0, 8. Because when I multiply 0 times 4, we get 0. And 2 times 4 is 8. Pretty simple, right? What about image B? What would image B be? Who could tell you what image B would be, Alexis? 16, 16. Because we're scaling it up 4 times. And then what about image C? What would image C be? Kevin. Negative 4, 16. So those would be the coordinates of our new shape, our image shape. We're going to do one more together before we turn you loose. Uh-oh. I lost, I've shifted my whole thing here, so let me go back. Okay. So we have a quadrilateral, PQRS, at vertices negative 2, 4. So that's P. Q is 4, 4. R is 4, negative 2. And S. So here is our shape. Okay. Now the scale factor is dilated by a scale factor of a half. So our shape can be bigger or smaller than the original. Smaller, because the growth factor, or not growth factor, your scale factor is between 0 and 1, right? So, if we go ahead and write the original, because sometimes it just helps to see. When you're doing the math. Okay. So, if the scale factor is a half, what would the new coordinate be of P, the image? Armando. -1, 2. Right, because you multiply -2 times a half, which is -1, and 4 times a half is 2. So our new coordinate goes right there. What would the image coordinate be of Q? If original is 4, 4. Jordan. 2, 2. Right there. All right, what about image R? What would image R be, Brittany? Yep, 2, -1, which is right here. And what about S? What would S be, Armando? -2, -2, which is right there. So our shape fits inside the original because the scale factor is less than 1, so it reduces. All right, real quick on the back, I want you to try this one. Now, a lot has been done for you already, right? They have both figures up there. Well, your job is to see if you can find the scale factor. Okay? So, I'll draw it in red. This is your original shape. How do you know that? How do you know that the one I just drew in red is the original shape, Tim? Yeah, and the inside, if you notice, B has the apostrophes on it, signifying the image. So that's the transformation shape, right? So the red is the original. So this is what kind of the scale factor should be what? What should your number be roughly about between what two numbers? 0 and 1, right? All right. So I'm gonna give you guys just a little bit to see if you guys can figure it out with your shoulder partners. What would the scale factor be? For example, 4. We'll pause. If you look at the original coordinates for A, B, C, D, you are at 6, 0, 0, 6, -6, 0, and 0, -6. And then if you look at the coordinates of the images, 2, 0, 0, 2, -2, 0, and 0, -2. So from 6 to 2, you're dividing by 3, right? But we don't do dividing here. The scale factor is multiplication. So to get that, your scale factor had to be 1/3. Because 6 times 1/3 gives you 2. Or -6 times 1/3 gives you -2. So your scale factor here was 1/3. Remember, for it to be a reduction, which means when it goes smaller, right, that number has to be between 0 and 1, that scale factor. If it's bigger than 1, we're enlarging it. Okay? All right, so take that and try to do number 5 now. So triangle XYZ is graph below. You're going to draw an image triangle with a scale factor, a dilation of scale factor of 2. 2. So x was at 1, 1 here. Oh, not 1, 1. Negative 1, 1. Negative 1, negative 1. There it goes. Y is at negative 1, 2. And z is at 1, 1. So I want you to come up with the image triangle. And let's see how that looks. And then they got a little special bonus question below. What will the coordinates of the second image of y be if we reflect that over the x-axis? So you got to come up with your triangle first, and then just let me know what the point y would be. See if you guys remember I kind of showed you that little trick yesterday. All right, so we're going to pause and give you guys. So what would be the image coordinate of x? What would be the new coordinate of x if it's a scale factor of 2? Claudia. Yeah, negative 2, negative 2. Because I'm just taking negative 1 and negative 1 and multiplying those each by 2. So negative 2 is right here. Okay, what about the image of y? Owen?
Negative 2.
Yep, negative 2. Because that's what I get when I multiplied negative 1 times 2 and 4. Because 2 times 2 is 4. And that is way up here. There we go. And image z. What would image z be, Tim? 2, 2. Which is right there. So here is your image, right? Okay, now, what will the coordinate of the second image of y be? So this right up here, if we reflect this through the x-axis. So where would image y end up if we reflected that? Tim? Negative 1, negative 2? Got to be a little deeper than that. How far is y from the x-axis? Huh? How many units is image y from the x-axis? Huh? How many units away is the point image y from the x-axis? 4, right? So if it's 4 above, to reflect it, we got to go 4 below. 1, 2, 3. It would wind up right here. What is that coordinate? What is that coordinate I drew? Negative 2, negative 4. And if we were to go one step further, if I were to reflect the whole thing, well, x would have to be 2 above, so right here. And then z would have to be 2 below, which is right here. So if we were to reflect the whole shape, this is what it would look like. Let's flip it upside down. All right, so you can use the remainder of the class time, which is a half hour, to practice.